All right, so let's picture this. We're floating in space, and in front of us is this colossal cloud of gas and dust. It's cold, it's scattered, but it's alive with potential. Astronomers call them nebulae, and these are the actual nurseries of stars. One of the most famous is the Eagle Nebula. And if you've ever seen the Pillars of Creation image from the Hubble telescope, then yeah, you've already seen it. It's this epic sight where thick columns of dust, towering light years high, are just, well, brewing new stars. Now here's what's fascinating. These clouds don't just sit around doing nothing. Over time, gravity starts to pull chunks of gas and dust inward. I mean, we're talking massive amounts of material, compressed tighter and tighter. And the heat skyrockets as pressure builds. This is what we call gravitational collapse, and it's kind of the first act in a star's life. Eventually, in the heart of all this chaos, a protostar is born. Think of it as a baby star. It's not glowing brightly just yet, but it's generating heat, and it's on its way there. As the temperature shoots past millions of degrees, something pretty magical starts happening. Nuclear fusion. And by the way, fusion is what gives stars their brilliance. It's like the engine that powers them, fueling them by fusing hydrogen into helium and releasing an insane amount of energy in the process. Now, about the earliest stars ever, these so-called population 3 stars might have been the first to ever light up the universe. The cool thing is, these guys are long gone, but they played a huge role in shaping the cosmos. They were like pure hydrogen and helium, forged right after the Big Bang. Scientists are still piecing the story together, but these stars likely kick-started the formation of heavier elements. Everything from carbon to the oxygen we're breathing right now. I mean, it's kind of amazing to think about, isn't it? And it's not just beauty, there's still so much more we're learning. Cutting-edge telescopes like James Webb are giving us glimpses of these cosmic nurseries like no other. With these systems, astronomers are decoding how the earliest stars emerged, evolved, and shaped the universe as we know it. So, here's something mind-blowing to think about. The mass of a star basically decides its entire life story. I mean, the universe really doesn't do one-size-fits-all when it comes to stars. Take red dwarfs, for example. These small stars are like the marathon runners of the cosmos. They just keep burning hydrogen at this super slow and steady pace. These stars can live for tens, even hundreds of billions of years. That's way longer than the universe has even existed so far. Now, compare that with massive stars, the real giants. Their lives are like fireworks, short and incredibly intense. These stars burn through their hydrogen supply in, just a few million years, a blink on the cosmic scale. The bigger the star, the faster it consumes its fuel. And that's kind of fascinating, right? It's almost like they can't help but live fast and burn out dramatically. Okay, let's zoom in on this process a bit closer. Nuclear fusion. It's the heart of every star, literally. In stars like our Sun, what you've got is hydrogen fusing into helium in the core. Steady, consistent, like clockwork. But in these massive stars, fusion gets turbocharged. Because they're so hot and so dense, they can go beyond just fusing hydrogen. They start whipping up heavier elements, helium into carbon, carbon into oxygen, and so on, all the way to iron in their cores. And that brings us to Betelgeuse. If you don't know it, it's this red supergiant in the Orion constellation, and it is just, enormous. Seriously, if it were in our solar system, it would probably stretch out past Jupiter. Betelgeuse is in the last stages of its life right now. And get this, it's on the verge of going supernova. At some point, it could be next year or, 10,000 years from now, it's going to collapse in on itself and explode in one of the most spectacular endings a star can have. Astronomers are keeping a close watch because, it'll be the kind of light show that you can see during the daytime here on Earth. What's wild about supernovas, like the one Betelgeuse is heading towards, is that they give back to the galaxy. They scatter all those heavy elements, iron, gold, even uranium, into space. Kind of like sowing seeds for new stars, planets, and even life itself. Without these massive stars saying their explosive goodbyes, the universe literally wouldn't have the chemical diversity it does today. All right, let's dive into the grand finale of a star's life. And spoiler alert, it's anything but quiet. Stars, depending on their size, go out in dramatically different ways. You've got the massive stars that end their lives in these cataclysmic explosions called supernova. These are some of the most energetic events in the universe. Think billions of times brighter than the sun. And that energy? It doesn't just disappear, it reshapes the galaxy around it. Now, not everything about supernova is the same. Astronomers classify them into different types. Type 1, which usually involves a binary system where one star basically steals matter from its companion, and Type 2, which happens when a massive star burns through all its fuel and its core collapses under gravity. That collapse triggers the explosion. And what's left behind? Well, it depends. You might get a dense neutron star, or if the original star was large enough, you get a black hole. And yeah, black holes are just wow, right? These mind-bending objects where not even light can escape. Crazy stuff. Let's talk about a famous example of a supernova remnant, the Crab Nebula. This one blew up in 1054. And guess what? People on Earth actually recorded it. Historical accounts from China and the Middle East describe this object that was bright enough to be seen in daylight for weeks. What's left now is this stunning, sprawling cloud of gas and dust, but more than that, it's a cosmic recycling center. That remnant helps scatter elements like carbon, oxygen, and iron into space, elements that are crucial for, well, everything, including life here on Earth. And the cool thing about studying supernova is we're learning so much more than just how stars die. These explosions help astronomers map out the expansion of the universe. Yes, that's how we figured out it's speeding up, by the way. And they've been crucial in piecing together how galaxies form and evolve over billions of years. Every flicker of light from a distant supernova tells a story that stretches across time and space. Ultimately, it's this cycle of life and death that makes the universe endlessly fascinating. Stars are born, they live and they die, leaving behind elements that seed the next generation of stars and planets. It's like a cosmic kind of poetry, isn't it? And on that note, that's all for today. Thanks for joining me on this journey through the life of stars. I'll catch you next time. Clear skies.